We continue Unit 17 with change of base, laws of logs, and expanding and condensing logs. There are times that you must use a calculator to evaluate a logarithm. However, calculators are only programmed to use the common logarithm, the logarithmic function with a base of 10. To evaluate logarithms of other bases, you must first rewrite it in terms of the common logarithmic function, and this is called the change of base formula. The change of base formula is log base a of x, where a is another base other than 10, is equal to the log base 10 of x divided by log base 10 of a. First, I need to use the change of base formula to rewrite. Then we will use the calculator. So we have log base 10 of 25 divided by log base 10 of 2. 25 is the x in the formula, and the 2 is the a. Now I plug this into the calculator. The log button, the log base 10 button, is right here underneath the x squared key. All we have to do is put in the 25 divided by log 2. And we get 4.64385,619. Want to round this to 3 decimal places, so this will be 4.644, or 4 and 644 thousandths. Log base 5 of 12. Rewrite this in terms of the common log. Use the calculator. Log 12 divided by log 5. And we get this long piece here, and we're going to round this to 3 decimal places. 1.534. 1 and 534 thousandths. Example 3. Okay, this is log base 10 of 5 divided by log base 10 of 0.5, that's 5/10. We get negative 2 and 322 thousandths. Example 4. First rewrite this in terms of the log, and now put it in your calculator, and I get non-real answer. Because this is a negative 4, remember I can't raise. If I was to rewrite this, that would be 10 to some power equals negative 4, and this right here makes this not possible. Combinations of multiple logarithmic terms can be combined together to make one single logarithmic term using the laws of logarithms. Here's the laws of logarithms. I have log base b of the m times n. This is equal to log base b of m plus log base b of n. If I have log base b of m divided by n, I can split this up. Log base b of m minus log base b of n. And the third property, log base b of m raised to the k power, this just comes out to the very front, so I have k times log base b of m. M and n must be positive. B cannot be equal to 1. We're going to use these laws of logarithms to expand the following expressions. We're not solving, we're just expanding right now. I have log base 10 of 5 times a times b. It says when I multiply, I'm going to separate each piece and put a plus in between them. So this is equal to log base 10 of 5 plus log base 10 of A plus log base 10 of B. And that is the answer. And next example, log base 5 of 8x to the third power. So this is using two of them. Right here I have a multiplication, so I'm going to take care of this first. Log base 5 of 8 plus log base 5 of x to the third. However, I still have a 3 exponent, and when we expand, I cannot have any exponents or two numbers next to each other. So I'm going to rewrite it, and that will give us log base 5 of 8 plus 3 times log base 5 of x. Example 3. This is a division, so we're going to rewrite it. Log base 10 of a to the 5th minus log base 10 of b to the 3/2 power. I still have exponents. I cannot have exponents. I want to move those out. So this is taking 2 steps. Out to the front. So I have 5 log base 10 minus 3 over 2 times log base 10 to the b. Next example. This is multiplying. I also have exponents. This is equal to log base 2 of 6 squared plus log base 2 of x squared plus log base 2 of y cubed. I still need to take care of these exponents, and they move out to the front. This will give me 2 log base 2 6 plus 2 log base 2 x plus 3 log base 2 y. And this one is done. We're going to use the logarithms to condense the following expressions. That means, condense means to make smaller. So since there's an addition sign, we are going to use multiplication, but I also need to remember to bring this 3 back up as an exponent. So I will do this first. Log base 5 of 7 plus log base 5 of x to the third. Now I want to condense them. Since this is adding, we're going to multiply those together. So log base 5 of 7 times x to the third. So my answer is log base 5 of 7x to the third. Next example. First thing I notice is I'm going to have an exponent here and here, so I need to take care of those. So I have log base 6 of m to the third minus log base 6 of n to the 1/2. Now I notice there is a minus sign here, and when we subtract, we need to divide to take care of the, and that's the second log law. Now notice that we have a subtraction symbol, so this means we need to divide when we condense. So I have log base 6 of m to the third divided by n to the 1/2. This is log base 6 m to the third. N to the 1/2 is the square root of n, but we do not write the little square. Next example. I notice that I have a 3 out front, so that needs to come up here. So let me take care of that. Log base 2 of x cubed minus And inside parentheses here, I notice that there's a plus symbol, so I can take care of this inside here, inside the parentheses. Log base 2 and then 4 times x. Now I have a minus sign, so it means I will be dividing. So log base 2 of x to the third divided by 4x, and we can still reduce because there's an x on top and x on bottom. So I have log base 2 on the top. If I get rid of one x, if I subtract the exponents, that leaves x squared on top and a 4 on bottom. Next example. Take care of what's in parentheses first according to PEMDAS. That still applies. And there's a minus sign here. So this is log base 3 of 32 divided by 8 plus 1/3 log base 3 of 1 divided by 64. Now I want to take care of these exponents because I know I have some exponents here. 32 divided by 8 is 4. So I have log base 3 of 4 squared plus log base 3. This is 1 over 64 raised to the 1/3 power. Log base 3 of 4 squared is 16 plus, this is log base 3 of the cube root of 1 over 64. So log base 3 of 16 plus, this right here is log base 3, and then the cube root of 1 over 64 is 1 over 4. So now I have the plus sign I need to take care of. And this is going to leave log base 3 of 16 times 1/4, which gives me log base 3 of 4. Wow, that was something else. And that is the end of our Unit 17 Foldable.